This is Brian Putt. Today I'm going to talk to you about the pipeline maintenance policy with SIPmath in native Excel. We will determine the best pipeline maintenance strategy considering the possible impact of a pipeline event. The maintenance spend should be under the budget 80% of the time. We will utilize the free SIPmath toolbar to generate the decision and simulation model, and then utilize Excel Solver to optimize the maintenance program. As a reminder, the genesis of this whole model was that in 2010, a 30-inch pipeline, steel natural gas pipeline, that was installed over 50 years ago exploded in a residential area 2 miles west of San Francisco Airport. 8 people died and 38 houses were demolished, and it took 60 to 90 minutes to turn off the gas. It generated a crater 167 feet long and 26 feet wide and 40 feet deep. Just imagine how big that is. PG&E was forced to undergo a transformation that caused it to examine its maintenance schedule and pipeline replacement program. Of the 48,000 miles of pipe, the question was, which should be inspected, repaired, and replaced first to mitigate the decision? And what is the value measure the PG&E should use that was in the best interest of the public? So for our simple model, this is the influence diagram. There's a likelihood of failure of a pipeline with and without mitigation. There's a likelihood of failure with an earthquake, with and without mitigation. We have the probability of the earthquake, we have the decision policy, we have the cost of occurrence, and we have the mitigation budget. This is all brought together into a total cost of the events plus the total cost to include the mitigation. And just as some core information, generally the higher the event cost over here, here are 5 pipelines we're going to look at, the higher the mitigation cost. And so the question becomes, which of these pipelines should be mitigated consistent with our budget? Here are the probabilities of an event with and without earthquake. If there's no event, probability of the event with no mitigation is shown here. If we have an earthquake, it increases. So let's experiment with the model. So here's our model. We have 5 pipelines. The residential high density commercial area, there's one in the country, there's one along the highway, and then there's a residential 2. So we can either decide to mitigate or not mitigate these 5 pipelines. There's a probability of earthquake of 20%, mitigation budget of 18 million, required probability of being less than the budget 80% of the time. And if I don't mitigate anything, I have a 100% chance of being under my budget. This chart here shows the total cost to include the risk plus the mitigation cost. And the dashed black line represents the reference case. That is doing nothing. And then over here we show the mitigation costs. Now what I want to do, if we were to do all of these pipelines, so I'm just going to do all of the pipelines. What happens? Well, here was our reference case, and it had roughly a 3% chance of being under budget, or excuse me, 3% chance of having an event. If I mitigate everything, now there's a 65% chance that I'm not going to have any incidents, no events. And my cost has been reduced from 107 down to 45. That sounds super, okay? The only problem is that now my budget is way over. There's effectively no chance I'm going to be within the budget. So we need to make a decision on which of these 5 events to mitigate. So let's take a look. Let's put them all back to zeros again. You notice as I do this the SIPmath is automatically updating all of these charts for me. I didn't have to do anything, say run or anything else. It all just happens automatically. So if I did the residential high density, make that a 1. So I'm going to mitigate that one. We see that, yes, we do reduce the probability of an event a little bit. The total cost appears to be down, but the expected value is actually a little. Oh, total risk cost is 99 versus 107. So it's a little bit better. And my cost of mitigation is way under budget, 99.8. Okay. What if, rather than doing that one, I were to run the commercial one? It goes from 107.4 down to 94, so that looks attractive as well. I'm still way under budget. Let's do one more, okay? And once again, I'm under budget and way under my risk costs and way under the budget. Okay. So if I had everything, let's come back here and ask a question. If I had everything, what kind of a budget would I need at 80%? So at 80%, if I did everything, I would need a budget of around 30.5. That's what I would need, but I only have a budget of, I have a budget of 18 here, so I really want to make that a 20 as my reference case. But that budget didn't change what I needed. I still needed 30.5. Okay, so let's store our reference case of 0 here. And what I've done is I've recorded a few key parameters. There's the EV cost, 107. There's no mitigation cost. Probability of no event is 3. And the cost of being under my budget target is 100%. So let me just take that. We'll copy that. And we'll stick it over here. And this is going to be our reference case. Okay? So now what do I want to do? Oh, I guess I had one over here which was all 1s. So let's put all that in. So these are the 2 bookends, if you will. We'll store that case as well. So those are the 2 bookends. I can't do any better than 45 here. Okay, so now the question is, we need to optimize this. So let me give it a case which is kind of feasible. At least it's feasible here. And let's go to Data Solver, and let's solve for an optimum case. Now in Solver, what we're going to do is we have to specify what we want to maximize or minimize. So in this case, we're going to minimize the total cost. We're going to adjust these variables, these 0, 1s, and they're going to be binary. And we've said H5, which is, H5. H5 is the probability of being under the budget has to be greater than or equal to the 80%. So we'll say solve. Objective cell must be a formula. H4. Oh, that's not right. It's supposed to be E. It's supposed to be this cost, right? Yeah. I'm not sure how it got changed. That's fine. So we'll say solve. Okay, we have an answer here, which says that we should do these 4 activities. We have a ED cost of 53.5, and we have an 85% probability of being under budget. So that looks like a pretty good case. So let's document that. We'll copy, paste values. Oh, I forgot. So this is my reference case, right? This is my reference. This is all, and this is with optimized 80 million, excuse me, with it optimized with 20 million as my budget. All right. Now let me ask a question. So first of all, the other thing we might want to ask, probability of event. Look, we've got a 42% chance of not having any event at all. Probability of no event. versus 3. So this looks like a really good deal. Not as good as this, though. So now let's ask, okay, so now comes, how many of you have been given an initial budget and then, or suggested budget, and then been told to reduce it? Probably all of you. So let's assume there's a 10% reduction in my budget here. So now I've got to go to 18. And so now we find out that this optimum portfolio that I had has a probability of being under budget only 72.5%, but I wanted 80%. So one question might be, well, how much would I need to add to get to the 80%? There we go. 19.13. So if I could get 19 million, not the 20, I could achieve my original optimization. Okay? But what if I couldn't get that? So now, what do I need to give up? So let me just take out one of these here. Let's take out that one, okay? And we'll go to our data solver again. And we'll see what we get here with the lower budget. We got the lower budget of 18, right? Okay, solve. And we have an answer. Okay. So in this case, we're 98.2% chance of being under budget. That's really nice. And a 64. How does that compare to our other one? Well, so this is a budget of optimum of 18 million, right? So if, I guess the question is, could we argue that if we could get 19 million, and we did this other task, leaving out the residential high security, we would have 79.8 with 53.5. Looks almost identical, right? It is just a hair different. Well, I guess it's identical answers. The only thing that's changed is the probability of being under target. And this is with a target of 19. This is with an optimum 19. I'm getting a little confused here, so we'll just do that. And then we'll copy that format over here, all of these guys. Okay, that looks good. That looks better. So the question becomes, would you be willing to ask for that extra $1 million? And the argument being that I can, with that extra $1 million, I can increase the probability of no event from 22 to 42. Oh, what we didn't do here, let's go back here to all zeros again. So we're not going to mitigate anything. We've got 107. And let's change this probability of earthquake. Let's have it, okay? 20%. We're at 107.5. Now we're at 92.7. And the probability of an event is only 5%. So this is the reference. Over here is the reference reference 20% earthquake, right? You get one more. You know, it really, that earthquake didn't really significantly change the probability of not having any events at all. So that's really not the key factor here. If I don't mitigate. So what have we learned? Well, using SIPmath, an analyst can easily test the simulation model for sensitivity and gain insights while building the model. These are manual sensitivities, what I would suggest while you're building the model. And with all those insights, you can convey them to management, and they may embrace a dialogue about uncertainty in various decision policies, and they can check, real time the impact of their own perceptions. I think this allows the management to be more involved in the decision making and accept the results. SIPmath facilitates that discussion with real-time results, as we saw in the example. And then the free SIPmath tool and Excel solvers are a good initial set of tools for models of moderate size. I think when you get to things much bigger, depending upon what they are, you might be better off with some other things such as Crystal Ball, OpQuest. But remember that the number of uncertainties in the model probably are not impacting the solve time. It's more the number of decisions, the variables that need to be changed, the decision variables. So where can you learn more? Well, probabilitymanagement.org has got a bunch of videos. I also have a YouTube channel where there's multiple videos on the application of SIPmath and doing analysis to include value of information, or you can contact me at brian@theputz.com. So if there's any further questions, be happy to answer them now.